So welcome students. Today we will discuss about the membrane modules. So basically, as I told you several times, that the membrane based separation process is the surface phenomena, and the amount of material separated out depends upon the surface area of the membrane. So at for industrial scale separation or the commercial separation, you need a lot of membrane area. But with the membrane area, you also need the volume of the or space where you can put that membrane. So in general, in the industrial scale setups or in the commercial step setups, we arrange the membrane in specific geometries which will provide the high membrane area in a given volume. That means membrane density. So that means higher membrane density. So higher the membrane density means the higher membrane area per unit volume of the equipment. So that type of equipments are called the membrane modules. So they are the different type of membrane modules used in the industry or the commercial scale setups. So today we will discuss about the different type of membrane modules. So first most simpler geometry is the plate and frame module. So this is the diagram of a plate and frame module. So this type of membrane modules are generally used in the lab scale setups or very small scale setups in the industry also. So in this setups, this plate and frame modules contain a frame. So this is a frame. So this is first part of the frame. This is the second part of the frame. In between you have a spacer. This is a spacer, and this is the gasket which used to seal this space where available for flow of the liquid. Then this is the membrane. Okay, so this can be joined like this. So here you have the feed which is flows from here and removed from here. This is the membrane, and product will comes from this side. So this is our dialysis setup where you have the 1 mole liquid in the product side. Also in the reverse osmosis you have the two input and one input and 2 output. This is for rejection side, and this is for the product side in the reverse osmosis membrane. So this type of geometry is called the plate and frame module. So here you membrane is situated inside a frame, and the flat sheet membrane sheets are used in this type of module. The next module which is more famous is the spiral wound module geometry. So in domestic membrane based separation processes which we used in the home appliances, reverse osmosis setups which we used in the home for the water purification, that contains the spiral wound modules. So spiral wound modules, in the spiral wound modules, membrane are situated like envelope type of structure. So this is a membrane, this is a envelope of a membrane. So it is sealed from the 3 sides. So this side is sealed, this side is sealed, and this side is sealed. Okay, and above this envelope you have a spacer. So this is a spacer. Spacer means there is a net of the polymeric net which provide this provide the space for flowing the liquid. So this is the spacer, and there is a spacer inside the envelope also. So this is the envelope, and inside the envelope also there is a spacer. So feed will flow from enters from in this direction and leaves from this direction above the envelope. Okay, and due to the pressure the water will permeates across the membrane and collected inside the envelope, and then it will move in this direction, and there is a perforated tube at the end of the envelope which is situated at the end of the envelope, and the liquid will collected inside this tube and removed from here. Okay, so this is this envelope will then the spiraled across this tube and make a cartridge. So the cartridge of the membrane which we will use in the home appliances, that is in the spiral wound geometry. So this type of geometry provide the very high membrane density, and most of the commercial size reverse osmosis setup or nanofiltration setups we use this geometry only. So here also we use the flat sheet membranes. Next is the hollow fiber axial flow module. So this geometry, this membrane module geometry contains a hollow fiber membranes. So I have already explained you in the previous lecture that the membranes might be in this flat sheet geometry as well as the hollow fiber geometry and the tubular geometry. So hollow fiber geometry, if the membrane is in hollow fiber geometry, we can use hollow fiber axial flow module. In this geometry, this is the similar to the shell and tube heat exchangers. Okay, so these are the membrane tubes. So feed will comes either from the tube side. So this is the entry point. Feed will enter from here, flows in this direction and remove from here, and the permeate will flow in the shell side. So permeate will comes from here and moves in this direction, removes from here. If it is a reverse osmosis, so permeates will just permeates out through the membrane. These are the membrane, these tubes are made from the membrane. So permeates just flows in this direction, collected in this chamber shell, and it will remove from this side. Okay, so shell and tube membrane, this type of hollow fiber axial membranes are used in generally in the ultrafiltration setups, and it is quite useful setups because the membrane densities are quite higher, but this type of setup only use the hollow fibers membranes. Okay, now next type of membrane modules are the hollow fiber radial flow membrane module. So this is the special, this is also similar to the axial flow membrane modules, but this is the special geometry, and these geometries are generally used especially when you have the very thin fibers. So this geometry, this is the specific membrane geometry, membrane module geometry, which is used for seawater desalination in by using reverse osmosis. Okay, so here there is a centric tube inside the module. So this is the tube. It is generally the perforated ceramic tube, and feed comes from this tube only. Or there are fibers in this direction. These fibers has a very thin diameter in the micrometer radius or diameter, and the feed flows in the radial direction from here to here. Okay, and then due to the pressure due to the higher pressure, the water molecules will permeates through the membrane and collected inside the tubes. Then due to the then it will moves from the this direction and collected in this side. The what this tubes are sealed in the this side direct in this end of the membrane. Okay, so here the permeate flows in the axial direction, and the feed flows in the radial direction. So this is called the hollow fiber radial flow modules. So why the feed is only flows in the shell direction, shell's side here, why not inside the tube feed can flow? Because the diameter in this module arrangement, the diameter of the tubes are very small. So if you want to push the fluid, push the liquid inside the at very high pressure inside the very thin diameter circular tubes, so it is very difficult. Pressure drop will be much higher inside the tubes. So generally the feed, which is the high pressure which is higher at the pressure in the reverse osmosis process, flows in the shell side only in this diagram. Okay, and here you will get the retentate, and from the tube side you will get the permeate. Okay, now this is the special geometry which is used for reverse osmosis and especially for the seawater desalination, where you need the very large membrane area because the fluxes are very low. In the seawater desalination, why the fluxes are very low? Because the concentration of salt are very high in the seawater, so you will get the very low fluxes, and the requirement of pressure is very high. So you use the very low fluxes, but you want to increase the surface area of membrane so that you will get the good recovery. For that you use the very thin fiber the very thin fibers of membrane, which will give you the very high fiber surface area per unit volume density, and you will get the good recovery of the permeate. Now next type of modules are the tubular modules. So basically tubular modules have the similar geometry as the axial for hollow fiber axial flow module. So both has the similar geometry. So in the tubular module also you have the tubes, you have the shell, and feed flows inside the tube, and the permeate flows inside the shell, and both are in the axial direction. Flow both permeate and feed flows in the axial direction only. The difference is that in the axial flow hollow fiber module you have the fibers as a membrane. In the tubular module you have the tubes as a membrane. So this is the same concept, only the difference is you have the tube as a membrane. So this is the ceramic tubes. Generally the inorganic membrane are used in the tubular module only, because in this geometry you have the higher strength of the material in the inorganic membranes, if the membranes are inorganic. Okay, now there is a comparison between the different types of module, especially for the reverse osmosis process. So this is very important for exam point of view, so you have to remember this. So first this is the tubular geometry, then spiral wound geometry, hollow fiber geometry, hollow fiber axial flow geometry, hollow fiber radial flow geometry, and plate and frame geometry. So we have already studied all the 5 types of module. So first comparing criteria is the packing density. Packing density means how much membrane area is available per unit volume. So the unit is feet square per feet cube. Okay, so the packing density of tubular membranes, the smallest packing density is the tubular membranes module, because is the 30 to 50. Why it is very small? Because the size of the tubular membranes are quite large, so you have the less amount of membrane area in the per unit volume of the the reactor, or per unit volume of the module. Okay, the next is the patent frame, 35 to 50. It also has the very less density. Spiral wound module has the 250, which is sufficiently good. Then hollow fiber has the 1000, and the hollow fiber axial flow has the 1000, and highest is the hollow fiber radial flow, 5000 to 10,000. Why the hollow fiber radial flow has the highest packing density? Because the fiber size is generally in the micro, in the radius or diameter of the fibers are in the micron size. Okay, micrometer size. So you have the very high fiber density or the surface membrane surface density in a given volume. Okay, next comparing criteria is water flux. So water flux, you will get the higher water flux in the tubular, spiral wound, and plate and frame module. Why? Because the pressure drop across the module is very less in these geometries. So you have the sufficiently good flux, like 10 gallon per feet square per day from the tubular module, as well as from the spiral wound module, as well as from the plate and frame module. But in a hollow fibers module, you have this lesser flux. Why? Because the pressure drop across the system is quite higher. So this is the pressure driving process, reverse osmosis. So if you have the pressure drop across the system, you will get the lesser flux. As well as the generally these type systems are used where you have the higher concentration of salts. So of course you have the lesser flux, but that can be that can be compensated by the higher density. So the unit of flux is gallon per meter square per day. So gallon of water collected per feet square of membrane area per day or per unit time. Okay, so you have the lesser flux in the radial hollow fiber membranes, but the membrane density is quite higher. So suppose you have a feet cube volume of the equipment, so you will get the quite higher water flux. Why? Because that you have the quite higher water recovery. Why? Because the water flux is low, but again membrane area available is quite high. So when you multiply this flux to the membrane area, you will get the amount of water which is collected per day, gallon per day, in the unit will be gallon per day, and that will be very high because the membrane density is very high for the hollow fiber radial modules. That's why these modules are used for seawater desalination. Okay, next is the salt rejection. So salt rejection is some property which depend upon membrane, not the membrane module geometry. So it is good for all type of membrane modules. So this property does not depend upon the membrane module geometry at all. This property depend upon the type of membrane you are using. So this will be good for same for the all type of modules. Next is water output. How much water you can collect per meter cube of the equipment size. Okay, so you can see that in this data you can compare if you this data to the flux. You can see that the hollow fiber radial modules has the lesser flux but higher water output. Why? Because the membrane densities are quite higher. Okay, and similarly you have the from the spiral wound module you have the 2500, from the hollow fiber axial module you have the 5000. This is also quite high. So the hollow fiber modules have the lesser flux but higher water output capacity. Why? Because the membrane densities are quite high. and you have the minimum water output comes from the tubular module and the plate and frame module. That's why these two types of modules are used in the lab scale setups only, not in the commercial scale setups. Okay, now the water channel flow channel size, why this is important, because this data will depend upon the how much pressure drop occurs across the membrane. So in the tubular module you have the diameter of tubes from the 0.5 to 1 inch. In the spiral wound module, the size of the thickness of the flow channel, which depend upon the spacer, is 0.1 inch, which is quite lower. In the hollow fiber axial module, you have the diameter of fiber is 0.254 inch, so this is also quite lower. But in the hollow fiber radial modules, you have the diameter of the fiber, which is 0.002 inch, so this is quite lower, it is in the micrometer range. So basically you have the quite lower membrane radius in the hollow fiber radial module. That's why you have the very high packing density, because if the diameter of the fiber is very low, you can accumulate a lot of fiber in a given volume, so your density of the fiber will be very high. Next is the plate and frame module. In plate and frame module, the diameter of the flow channel will be 0.01 to 0.02, which is sufficiently less. So you have very high pressure drop in the hollow fiber radial modules, and but you have the high water output. Okay, now the cleaning is also important phenomena, because if you clean the membrane easily, you can remove the fouling and fouled material which is accumulated on the surface of the membrane. So it is important when you are using this type of process in the food industry or biotechnological industry, where the material might be accumulated on the surface of the membranes. So in the tubular modules it is very good. That's why tubular modules are generally used in the food industries. In spiral wound module it is fair, so spiral wound modules are used for domestic water purification system. And before spiral wound module, we use the cartridge for removing the particles, as well as the carbon cartridge for removing the gases. So water should be pre-treated before going to the spiral wound module, otherwise your membrane will be destroyed very quickly. So we use because you don't want to clean the membrane repeatedly, so you use the pre-treatment of water in the domestic setups. Next is the hollow fiber axial module. There also you have the fair separation cleaning process, and it is good in the plate and frame module. That's why we use, because if you want to do some experiments, you want to clean the membrane very easily, so you use the plate and frame module in the laboratories. Then in hollow fiber radial module it is poor. So why it is poor? Because membrane densities are very high. When a lot of fibers are accumulated inside a small volume, then it is very difficult to clean the membranes. So it is very poor the cleaning process is very difficult in the hollow fiber radial modules. So these are the comparison of the different type of modules, especially for the reverse osmosis process. And if you want to, so based on this comparison, you can select a membrane module for a specific purpose. But generally the thumb rules are, if you are using the reverse osmosis, either you can use the reverse osmosis for domestic purpose, or for a small scale purpose you can use the spiral wound modules. If you are using the reverse osmosis for the seawater desalination, then you can go for the hollow fiber radial modules. If you are using the ultrafiltration membrane, then you can use the hollow fiber axial module. If you are using the inorganic membranes or ceramic membranes for some type of membrane reactors or food industry or in the biotechnological industry, you can use the tubular modules. And if you want to do the experiments in the laboratory, you can use the either tubular module or the plate and frame modules. So this is the comparison of different type of membrane modules used in the processing industry.